The next topic that we want to look at is called linear models and applications. So the goal for us here is going to be starting with some sort of verbal expression and turning that into the language of math. So just so you have an example of what we're talking about here, if you read something that says something like one number exceeds another by a, so that would mean that one number, x, is x plus a compared to the other. So the second number, x plus a, is a more than the original x. Next, twice a number, that would mean that you multiply by 2. So by the same account, 3 times a number or thrice a number would be 3 times x. You could go from there. Next, one number is a more than another number. So this is the same as the first one. We're just saying that one number, we'll call it x. We have another number that is a more, so x plus a. One number is a less than twice another number. So when we say less, we're talking about subtraction. And when we say twice another, we're talking about 2 times that number. So a less than twice another number. So that would be 2x minus a. Next, the product of a number and a decreased by b. So the product is multiplication. So the product of a number and a decreased, so subtracted by b. Next, the quotient of a number and the number plus a is 3 times the number. So when we see the word is, that's kind of a hint to use the equal sign. So the quotient of a number, that would be x, and the number plus a, so there's your quotient of the number and the number plus a, is, so equals, 3 times the number. Next, the product of 3 times a number and the number decreased by b is c. So this is, again, is the equal sign. So when we say is c, we're going to say equal to c. The product, that means multiplication, of 3 times a number, so there's my 3 times a number, and the number decreased by b. The number decreased by b, so there's multiplication, is equal to c. So whenever we're going to be solving these real-world problems, there's kind of 5 steps involved here. First thing you need to know is you need to identify the quantities. Then from there, assign variable to represent all of these unknown quantities. And if there is more than one unknown quantity, find a way to write the second unknown in terms of the first. You don't want to have a bunch of variables just floating around if you can avoid that. So you kind of want to try to write quantities in terms of just one variable. Next, write an equation interpreting the words as mathematical operations. That was the examples that we just did. And then lastly, solve the equation. So first thing here, we're going to find a linear equation to solve for the following unknown quantities. One number exceeds another number by 17, and their sum is 31. Find the two numbers. So the first thing that we're going to do is we're going to write down what are we looking for. So we're saying that one number, we'll call that x. This is our first number. Exceeds another number by 17. So our second number, if this one's x plus 17, then x would be our second number. Then the sum is 31. So I know that if I add these two together, I should get 31. So my equation here is going to be x plus 17 equals 31. And to solve this, we'll do 2x, because x plus x is 2x, plus 17 equals 31. Then we will subtract 17 from both sides, so I'll get 2x equals 14. Divide by 2, and I get x equals 7. So one of our numbers is 7, but then the question is, what is the other number? Well, remember the other number was x plus 17, which would equal 24. So my two numbers are 7 and 24. In our next example, we have two cell phone companies, then they offer different packages. Company A charges a monthly service fee of $34 plus 5 cents per minute for talk time, and Company B charges a monthly service fee of $40 plus 4 minutes of talk time. For the first part of this, we're going to write a linear equation that models the packages offered by different companies. So we'll start with A. All of this is dependent on how much you talk. So what we need to do is say that x is the number of minutes of how much you talk. Then for company A, they're going to charge you $34 just for having a phone, then plus 5 cents for every minute. For company B, they're charging you a flat fee of $40 and then 4 cents for every minute that you talk. So those would be our two linear equations. Next B, if the average number of minutes used each month is 1,160, which company offers the better plan? So here our x is equal to 1,160. So what I'm going to do is I'm going to plug this into each plan and see what happens. So if I plug this into A, I'll get 34 plus 5 cents times 1,160. You can feel free to type this in your calculator, but I got $92. For company B, theirs was 40 plus 4 cents times 1,160, and that gave me 86.40. So I think if you were going to talk on average 1,160 minutes each month, it looks like company B would be the better choice for you. Now let's say that the average number of minutes each month is only 420. Which company offers the better plan now? So we'll do the same thing. We'll plug in 420 to each equation. So 34 plus 5 cents times 420, which I got $55. And then for company B, 40 plus 0.04 times 420, I got 56.80. So company B was the better plan when I talked 1,160 minutes. Looks like company A now, though, is a little bit cheaper. So if I only talk 420 minutes, I should go with company A. Next, how many minutes of talk time would yield equal monthly statements from both companies? So we're asking to solve for X. So I want to know for what number of minutes are both these going to be equal? So we'll take the two equations and we'll set them equal. And so if we're going to solve this, there's a couple different ways that you could go about this, but I would probably start by subtracting this 0.04x on both sides. So that would give me 34 plus 0.01x equals 40. Next, I'll subtract 34 from both sides, so 0.01x equals 6. And lastly, I will divide by 0.01 and I get x equals 600. So it looks like if you talk 600 minutes a month, then both of these plans will give you exactly the same amount of money that you would have to spend. For our next problem here, it takes Andrew 30 minutes to drive to work in the morning. He drives home using the same route, but it takes 10 minutes longer and he averages 10 miles per hour less than he did in the morning. How far does Andrew drive to work? So a couple things here. We have minutes being used, but then later on we have hours. So we need to go ahead and decide that we are going to use miles per hour. So we're going to convert everything to hours. So that's going to be key. And we can't write down minutes in terms of our formulas when we go to do that because we have minutes and hours being floated around. We're going to just use hours. So we'll have to convert. Next thing we're going to use is we are going to use the distance formula. So distance is equal to the rate that you're traveling times the time. So something like if you're traveling 30 miles per hour for 2 hours, then you have traveled 60 miles. So it's the rate that you're traveling times the time that you're traveling. So let's let all of this happen. On Andrew's way to work, the distance that he traveled was whatever rate he was driving times that 1/2 hour that it took him to drive. On his way home, though, the distance that he traveled, well, he went 10 miles per hour less. So his rate was the original rate minus 10. And his time was 2/3 of an hour because it took him 10 minutes longer which is 40 minutes. 40 minutes is 2/3 of an hour. So 40 minutes equals 2/3 of an hour. So how far does he drive to work? We're looking for this distance. So I'll just set the two equal. If I know that d is 1/2 r, but I also know that it's r minus 10 times 2/3, I can go ahead and just solve those. So I'll say that 1/2 r is equal to, and I'm just putting this coefficient out front, which is okay. Completely up to you how you solve this. I think because there are fractions involved, I probably want to get rid of those fractions first. So I'm going to multiply both sides by 6, and that should get rid of my fractions. So 6 times 1/2 is 3. 6 times 2/3, well, this 3 and that 6 will reduce down to 4. So I get 4r minus 10. Next, I will distribute that 4. So 3r is 4r minus 40. I'll move the 3r over to the other side, and at the same time, I'll move the negative 40 over to the other side. So 40 equals r. So it looks like he's driving 40 miles to and from work. In our next example, we're going to look at the perimeter of a rectangular outdoor patio. So I have this patio. I want to know the dimensions. So in this patio, I know that one of them is the length and one of them is the width. But what I do know is that the length is 3 feet greater than the width. So I can label these as one of them is L and one of them is 3 more. It doesn't matter which one you label the length and which one you label the width. The important thing is that one of them is 3 more than the other. What are the dimensions of the patio? So I know that the perimeter is 54 feet. But also, if I go ahead and add up all 4 of these sides, I can set that equal to 54. So that'll be L, and I'm just going clockwise around the rectangle, L plus 3 plus L plus L plus 3. So I have 4 L's there and 6. I'll subtract 6 from both sides, and that gives me 48 is 4L. Then I'll divide by 4, and I'll get that L is 12. As far as what is the width of this going to be, remember the width was 12 or 3 more, so the width is going to be 15. So my dimensions are 12 feet by 15 feet.